in a pipe or in a containers. There is a low pressure measurements, possible a high, medium pressure, everything, right? So first part one, basically there are three pressure sensing elements. One is that first is the Bourdon tube, second one is the bellows, and third one is the diaphragm, right? So basically this Bourdon tube, bellows, and the diaphragm, these three pressure sensors that are known as a elastic type pressure sensors. Okay, Bourdon tube, bellows, and the diaphragm that are known as a elastic type pressure sensors. Now, question is that what is the meaning of this elastic type pressure sensors? Okay, so elastic type pressure sensor means suppose a pressure, suppose there is a body elastic element. So when we put some pressure, okay, inside the body, then what will happen? It deforms, okay, it changes the shape of the body, okay, it changes the shape of the body. So now that the change of the shape of the body, that can be measured by using any transducers. Okay, so that is the elastic type of pressure sensing elements. Understood? So first thing is that what is that Bourdon tube? This is, you can see the basic structure of the Bourdon tube. Okay, it's the main structure of the Bourdon tube. Basically, it is a C-type Bourdon tube. Okay, that is the C-type structure. Okay, and except the C-type Bourdon tube, there are so many types like helical type Bourdon tube, spiral type Bourdon tube, but mostly the C-type Bourdon tube is used. The advantage is that it is very simple in construction. Okay, it's very simple in construction. So that is the main advantage. That's why that C-type Bourdon tube that is used. Okay, and this Bourdon tube actually basically that is very low cost. This is another advantage. It is a very low cost. Okay, and application is that basically Bourdon tube can be measured in the hydraulic pressure measurements. Okay, hydraulic pressure measurements, or we can see in the local application like that foot pump. Okay, in the foot pump, the Bourdon tube is used to pressure to give the reading, the analog pressure readings. Okay, so that is the applications of the Bourdon tube. Okay, so this is the C-type structures. Okay, so now actually what is happening here? The Bourdon tube thing is that, so there are two ends. Okay, one is that fixed end. Okay, this is the fixed end. Okay, and this end is free to move. This end is free to move. Okay, so this fixed end, okay, is connected to a pressure tapping. Okay, there is a pressure tapping. Pressure tapping means through pressure inlet. Okay, through it we can put some pressure inside the body. Okay, so this is known as a pressure tapping. So this first end, okay, this fixed end that is attached with the pressure tapping. So from there, the external pressure from the initial condition, there are two conditions. First is the stationary condition. Initial conditions can. So when there is no pressure inside the body, okay, there is no pressure inside the body. So then what will happen? It will not change the shape. Okay, no deformations of the body. Okay, and we will not be getting any reading, pressure reading. We will give some pressure, means that pressure you have to measure. Okay, there is a maybe low pressure, maybe high pressure, maybe medium pressure. That thing you have to measure, right? So here, see, there are three sections. One is, this is the link. This one is called link. This one is called sector, and this one is called pinions. Okay, what is the need of that? Okay, these all are included. Okay, and this is known as a deflecting mechanisms. Okay, and that is attached with the free end of this tube. That is attached with the free end of these tubes, and a pointer is attached with this deflecting mechanism. A pointer is attached with this deflecting mechanism. Okay, what is the function of this pointer? This is the analog scales. Okay, through it we can measure the pressure reading because the pointer is rotating. Okay, pointer will rotate, right? So now how? So when the pressure, second condition, this is the condition one, when no pressure applied, so there is no pressure readings, right? Second condition, when the pressure is applied, right? When the pressure is applied, then what will happen? When the pressure is applied, pressure enters into the tube. Okay, pressure enters into the tube. Then what will happen? The tube tries to strengthen up. Okay, because initially the cross sections of this tube, first of all, this board is visible. This board is visible. Whiteboard.
Yes, sir.
Yes, sir.
Okay. So initially the cross sections of this tube, that is a elliptical, right? This is elliptical. Okay. So when the pressure is applied inside the tube, then what will happen? The tube tries to strengthen up, means it try to deform, and it will convert it as circular cross sections like that. Okay, it will, the elliptical cross sectional area, that will be converted to circular cross sectional area, right? So that things happens here. So when the pressure is applied, so tube tries to strengthen up. So this free end, the last end, this is known as a moving end. That is, it try to move up. Okay, this is try to move up. This one. Okay, this dotted sign is indicated that is a moving object. Okay, moving bend. It's try to bend. Okay, it's try to move up. So when this try to move up, when it moved up, then what will happen? Because deflecting mechanism already attached with this end. Okay, so when it is moving up, so immediately the deflecting mechanism will start rotating. Okay, so whole deflecting mechanism will start rotating, and the pointer is also attached with this deflecting mechanism. So when the deflecting mechanism will start rotating, the pointer will also start rotating. Okay, pointer will also start rotating. Okay, gradually. So accordingly, this movement actually depends on this magnitude of these pressures. The amount of the pressure means how much pressure we are applying. Okay, suppose we are low pressure is applied, so it will move slowly. It was a high pressure applied. Okay, it will move little bit first. But still, what is the disadvantage of this tube? I mean, what is the need of this actually is deflecting mechanism? The deflecting mechanism main use is that to amplify the readings. Okay, to amplify the pressure readings means what? Suppose that because this displacement or this deformation is very slow. Okay, it is very slow. Whenever the pressure is applied, the deformation of the body, the deflection is very slow. Okay, so deflection is very slow means we can say in other words, the signal is very weak. Maybe weak. Okay, so what is the need of the amplifier? Last day I told what is the need of the amplifier. Amplifier basically is used to amplify the signals. Okay, boost the signals, right? Increase the strength of the signals. So that's why this deflecting mechanism is used to rotate the pointers. Okay, perfectly, correctly. Okay, thus we can get we will be getting the analog pressure readings perfectly. Okay, how much pressure we are applying. Amplified reading. Actually, we will be getting some amplified reading. Okay, so this is the basic functions of this Bourdon tube. That is a C-type Bourdon tube. Is it clear?
Yes,
is
sir.
it clear to all?
Yes, sir.
Okay.
Yes, sir.
Okay, so this is very simple topic. This is elastic type elements, right? So you can see that one that is one video animations that actually how it is working. What I've said right now. See it. See it. That thing I have said right now. This is the link, this is sector, this is the pinions, right? And the pointer is attached. Now you've understood how the body is deforming, how it's changing the shape when the pressure is applied. And accordingly that we will getting some PSI readings, pressure readings. Now understood?
Yes, sir. Yes, sir.
Yes. So that is actually working. Okay. So with this Bourdon tube actually can measure that low to high pressure measurements. Okay. So some 0 to some 1000 psi. Okay. The Bourdon tube can measure. This is another advantage of the Bourdon tubes. Understood? So this is the main working of this Bourdon tube. Fine. So next is that another elastic type of pressure sensing element.
So what is the disadvantage of the Bourdon tube?
Disadvantage of Bourdon tube, that is already I have said, that is the displacement or deformation is very slow. Okay, the movement is very slow. Okay, each your body, this is the moving object. Okay, this is the moving end. Okay, and that is very slow. Okay, so that's why this deflecting mechanism is required to amplify it. Okay, so that is a disadvantage. We cannot attach the pointer directly with this end. Okay, through the deflecting mechanism, that we have to we have to take the readings, amplified readings. Now you have got it. This is the disadvantage.
Yes, sir. Yes.
Okay, this is a disadvantage. So now next topic is that it's a bellows. That is a bellows. Okay, that is the bellows. What is the bellows? Bellows is that one type of another pressure sensing elements. Okay, one type of pressure sensing element, you want to make elastic sensor. This is one type of elastic sensors. Okay, so actually what is happening here? So same thing, bellows actually depends on some convolutions. You are saying you can see, you can observe it, there is some folders. Okay, folders may known as the convolutions. Okay, convolutions, and the spring is loaded actually. The spring is loaded. Okay, so actually we can say that this is a spring, one of the spring type. Okay, there is a bellows, elastic type elements. So actually what is happening in case of bellows is very simple construction. When the pressure is no pressure is applied, then it's like Bourdon tube. When initial condition, first condition, when the no pressure is applied, then actually what will happen? No pressure applied means no displacement, no displacement. Because this is the fixed end and this is your free end, right? So this is your fixed end means like Bourdon tube. This end is attached to the pressure tapping. There is a pressure inlet through it that we have to apply the pressure, right? And this is your moving end. That is your free end. That is free to move. Okay. So when the pressure, no pressure is applied. No pressure applied means it will not move. Okay. No displacement, no deformations of the body, right? So now, second conditions, when the pressure is applied. Okay. When the pressure is applied inside the body, then what will happen? When the pressure is applied inside the body, it immediately deforms. It immediately deforms the shape. Okay, shape of the means that is the suppose the convolutions. This is actually made of some elastic elements, some materials. Okay, soft materials like Bourdon tube, where basically is made of some phosphor, bronze, beryllium, copper, and bellows also that is made of some phosphor, bronze, beryllium, copper. This type of metals. Okay, so now actually what is happening? So when the pressure is applied inside the body, so it causes some displacement. That is a X. Okay, it's called some displacement. Displacement means it deforms the object, deforms the end. Okay, it is free now. It is free to move. Now it is free to move. Okay. Now what is the function of the spring? Because spring is loaded, so we know that it is a basic concept. Spring is means oppose the limit. Okay, because it expands when the pressure is applied means it expands, and spring is limit the expands means oppose the movement, right? So we can say that the linear relationship we can obtain from there. So that is P equals to means what? Force means we know that what is the definition of the force? Force means F equals to P by A. Okay, P by A, right? So now, P by A means what pressure means force per unit area, right? P equals to F by A. P equals to F by A. So F equals to what we can say? That is P into A. Understood? P into A, right? So P into A that is equals to K into X, because P into A that is proportional to X. See to how much amount, because this displacement X depends on the magnitude of the pressure, amount of the pressure. Okay, so pressure is applied, then accordingly the displacement occurs. Okay, so we can say that P proportional to X. Okay, so P into A that is equals to, we can say K into X. What is the K? K is the spring constant. K is known as a spring constant, right? So P into A that is equal to K into X. So we can say that P proportional to X. P proportional to X. There's pressure that is proportional to displacement, right? So now if we attached with some deflecting mechanism like the Bourdon tube, like with the Bourdon tube. So now the some of the pointer is attached. Pointer is attached with the spring on the end of the and at the end point. So then what will happen when the displacement occurs? So then what will happen? Accordingly, the pointer will start moving. Pointer will start moving. Okay. So now this is the basic functions of this bellow. You can see this diagram, these animations. Also, you can see that. See here. See here. See here. This is not bellows. Okay, this is known as the number of convolutions, right? The pointer is attached. There is the advantage. There is an advantage of the bellows over the Bourdon tube. What is the advantage? See, there is no any deflecting mechanisms. Okay, no need to any amplifier, because the displacement is little bit faster than the Bourdon tube. Okay, so we can get some amplified signals. Okay, through the bellows. So this is the advantage, because here the no deflecting mechanism is attached, right? So now this displacement, if your displacement horai, you can see in this video, the displacement is occurring now. The displacement depends on this number of this convolution, means number of these folders. Okay, and this folder in industry may vary 5 to 20 numbers. Okay, number is 5 to 20. Suppose we are using the 5 folders. Okay, there are 5 folders, 1 2 3 4 5. So accordingly, we can the displacement, we can get the displacement maybe reach up to suppose 10 millimeter. Okay, so suppose we are giving some more than 5 folders, more than 5, that is like suppose 10 convolutions. Okay, so 10 convolutions is accordingly that we will be getting displacement more than 15, like 20 or 25 millimeters. Okay, so displacement basically depends on the number of convolution. That is the main point you have to keep it in your mind in bellows. Displacement, जो displacement हो रहा है यहाँ पे, that is happening x. That is depends on the number of convolution, the number of folders. Okay, because the internal spring is already loaded here. What I've said, the spring is loaded, right? So internally, so number of convolutions, displacement depends on number of convolutions, increase in displacement. Okay, suppose we are using the 5 convolutions, the displacement may get some 10. We will be using some, we will use some more than 5, like 10 or 15. So you can get a displacement reading like 20 more, 20 or 25 millimeter. Okay, so that thing is happening here, and no deflecting mechanism is here. No deflecting mechanism is attached with the free end. Only the pointer is attached, right? So this is the advantage. This is the advantage you can say that is over the Bourdon tube. And also there is an advantage that is a very easy to install, simple in construction. It can measure also the high to pressures measurement, medium pressure measurement. These are the advantages. Okay, so these are the advantages. And what are the disadvantages? Disadvantages of the Bourdon tube, or you can say the bellows. The disadvantage is that they are very not sensitive. They are not too much sensitive in some temperature variations. Okay, some mechanical hazards, vibrations, in shock. Okay, so wherever some vibration, shock occurs, some mechanical conditions, and temperature, high temperature. Okay, so then it may damage. Bourdon tube or pressure may be damaged. So they are not very sensitive. Okay, so that is the disadvantage of this Bourdon tube or the bellows. Okay, fine. Now it is clear. Bellows is clear.
Yes, sir. Yes, sir. Yes, sir.
Okay. Next topic is that diaphragm. Okay, diaphragm, you can say another type of elastic pressure, element, elastic pressure sensors like Bourdon tube and the bellows. Okay, so another advantage I forgot to say that bellows over the Bourdon tube, that is bellow is much sensitive. Okay, much sensitive than the Bourdon tube. Okay, because the spring is loaded, internal spring is loaded. That is why it's much sensitive. So now come to the diaphragm. Diaphragm actually, you can say there is one type of flexible membrane. Okay, that is one type of flexible membrane.
So,
Suppose, yes.
So the disadvantage of bellows, you said it's not too sensitive, and now you're saying it's more sensitive.
No, actually not sensitive to actually. So I am saying some temperature variation, some mechanical hazards, some environmental conditions. Okay, some the shocking vibrations. Okay, some vibrations occurs on the pressure. Okay.
So that makes it better, no? Because there is no random error while measuring.
No, that obviously get errors. No, that is a mega error, because they cannot withstand due to the high pressure, temperatures and high temperatures and shock and vibrations. Okay, some vibrations occurs, then it may damage. That is a disadvantage. It may damage due to shock and vibration. That is may damage. Okay.
Okay, sir.
Okay, so that is a disadvantage. Bourdon tube also. Okay, so this is also called, this is also shocking vibrations or mechanical hazards, external environmental conditions. Okay, right. So due to those, that they may get damage. Even the diaphragm also. These are all the common disadvantages. Understood? These are the common disadvantages. Fine.
Okay, sir.
Okay. So now, what is about a diaphragm? Diaphragm actually, you can say that is a thin plate. Suppose there is a plate, you can say that is a one type of membrane, flexible membrane. Okay. Suppose if you flexible membrane means this is one type of elastic body. Okay. So if you push, suppose if you push at the middle, so then what will happen? It will deform. Okay. It will deform. Okay. It will deform some. It will deform like that, some push, and will again move. It will again. So after pushing, it will deform. Okay, when it release. Okay, when it release the push button, then what will happen? It will restore its original position. Okay, it will restore its original position. So it is like some membrane, flexible membrane. So that is the one type of diaphragm. Okay, there is a diaphragm. Okay, so now you can say that in this diagram, so that is a thin plate. Okay, and that is attached with the some point, or it is some linkage. You can say that it is a linkage. Okay, there is a you flange. You can say that is a flange. Okay, so diaphragm basically this thin plate is attached with the two flanges. Okay, so now actually what is happening here? The same thing. That when the pressure is applied, no pressure is applied means no deformation. When the pressure is applied means pressure is applied, it is a sensing, this is a sensing area, this is all the sensing area. Okay, so when the pressure is applied from this side or from this side, when the pressure is applied, then what will happen? It will deform, it will change, but it is very change means not too much, but little bit change the shape. Okay, little bit change the shape. Okay, so little bit, when this change shape is very little bit, then less amount, then what will happen actually? Because you need to amplify it with thing. So directly you can attach the pointer. You can attach the pointer directly with this end. Okay, so similarly that you have to attach the deflecting mechanism like the Bourdon tube with this thin plate. Right, deflecting mechanism has to be attached with this thin plate. Okay, so now because deflecting mechanism, we know that, because already you know deflecting mechanism consists of this one link, that is a link that is sected and this is a pinion. So the same thing has to be attached with the diaphragm. When this deforms the body, change their shape little bit, so the deflecting mechanism will start rotating, and accordingly the pointer will start moving. So that means we are amplifying that reading. Because we amplify the reading, because suppose we have to measure some pressure 20 millimeter, 30 millimeter, 30 some psi's, suppose for examples. So suppose when some give some input pressure, but its deformation is the change, the displacement is very less. Okay, not too much, so larger. So then what will happen? The pointer will not reach up to that position. Pointer will not reach up to that direction. Okay, that point, that reading. So that's why you have to attach some externally. You have to arrangement some external mechanism. So that is the deflecting mechanism. So through deflecting mechanism, it's rotate. Okay, because there is a pinions. Okay, joint and link. So this is rotate. Rotate means that it helps the pointer to rotate to up to that reading. Suppose 30 psi, 40 psi, or 50 psi, we have to measure. Okay, we have to measure. It is our aim. Okay, so now that, so you can use here deflecting mechanism. So this is the another disadvantage of diaphragm. You can say that like Bourdon tube. Okay, the amplification is required. Okay, so these are the advantages and disadvantages, and all the common advantages. Common are simple in constructions, easy to use, flexible. Okay, and they can measure. And diaphragm is the one disadvantage is that diaphragm cannot measure to high pressure measurement. Bourdon tube and bellow can measure to high pressure measurement, but diaphragm is not able to measure the high pressure. Okay, so diaphragm is the one type of disadvantage. You can say that. Okay, so this is the basic elastic pressure sensors to this topic, the pressure sensor, Bourdon tube, bellows, and diaphragm. Now you have any questions that you can ask me.
Sir, can you share some real life examples like application where all of them are
Real-time
used?
examples, that is a hydraulic pressure applications, hydraulic pressure measurements, pneumatic pressure measurements in industry. Okay, in industry, because all the pressure sensors, the elastic pressure sensors, Bourdon tube, bellows, and diaphragm, mostly the Bourdon tube and bellows preferred because they can measure to high pressure measurement. Okay, diaphragm was second choice. That is second choice. Okay, but Bourdon tube and bellows would be first choice. Hydraulic pressure measurements industry, hydraulic fluid pressure measurements, pneumatic P2I to be converted, that is, you can use the Bourdon tube and bellow. Okay, and through the Bourdon tube, if we want to measure the electrical signals, high electrical output, because these are all known as the pressure sensors. You know, in the first class I have discussed the Bourdon tube and bellows, the diaphragm. These are all known as the pressure sensors. Okay, primary pressure sensors means it sends the pressures, but can convert to any electrical signals. Right? Can convert to any electrical signals. Means it just converts to pressure to displacement. Now, if you are to get some output reading, electrical reading is how much electrical output voltage we will be getting. We are reading suppose some amount of voltage. I aim to get some amount of voltage. So then you have to use some Bourdon tube real-time application, because Bourdon tube measure the high pressure measurement. So if you have high pressure measurement, that is proportional to high output signals, high output electrical signals. Suppose with the Bourdon tube, if you attach some LVDT. Okay, if you attach some LVDT at the end of the Bourdon tube, suppose at the end of the Bourdon tube you have some special arrangement. Yes.
Sir, a technical example, sir.
Technically,
टेक्निकल एग्जांपल एक दीजिए सर, कहाँ यूज होता है?
Technically, that is why I'm saying na I to P converter, P to I converter, I to P pressure to I converter, current to pressure converter, that boron tube is used. That is a process control application. That is a technical applications. Okay, I to P converter and P to I converter. Okay, that I'm not going in the details. That is why to I to P is about the process control. You will be studying in the next class, next semester, the process control. Okay, practical application is that I to P converter and P to I converter that is used in the boron tube. Okay, boron tube and as well as the bellows also used, but not diaphragm. Okay, the disadvantage is that one thing, the diaphragm cannot measure the high pressure measurements. Understood?
Yes, sir. Sir,
This is a technical application. Yes, tell me.
थोड़ा सा स्लो बोलिए सर.
हाँ बोलो. Technical applications. The technical application is the process to pressure to I current converter and current to pressure converter, P to I and I to P converter. Okay, this is one type of chemical process industry, technical specification. The chemical process industries and food process industries, whatever the pressure sensors, so many pressure sensors are used, like boron tube, bellows. Okay, diaphragm also used, but diaphragm is the not boron tube, and the bellows is the most preference. First preference will be the first preference on the boron tube and bellows. Diaphragm is the second preference because that one disadvantage is that diaphragm basically cannot measure the high pressure measurements. Understood? So that is the disadvantage. So these are the practical application, real-time application in the process, because these are all sensors and transducers that plays the critical role in the process industries, chemical industries, food industries, machinery industries. Okay, so these are the applications. Now, if you want to measure some electrical signals or electrical output voltage, so now what we will do? The electrical signals. Okay, suppose the boron tube, suppose some amount of pressure we have applied, accordingly that we will be getting some output voltage, output signals. So now how will you receive the output signals? Okay, through the LVDT. If the LVDT, linear variable differential transformer, that is applied or that is joined, linked with this end. Okay, so accordingly we will explain the LVDT is construction working the next class. No, not for that, but for examples that you should know that how this is the very analytical questions, that how you measure some displacement output voltage electrical signals to the boron tube. So LVDT displacement transducers that it can use, it is a type of inductive transducers that converts to displacement. The displacement हो रहा है ना, so displacement that is converted to electrical signals, electrical voltage. So there is one type of applications. There is another application. Industry में यूज होता है, केमिकल प्रोसेस इंडस्ट्री में यूज होता है, केमिकल इंडस्ट्री में. ठीक है, तो मुझे आउटपुट वोल्टेज चाहिए, आउटपुट वोल्टेज चाहिए, कितना आउटपुट वोल्टेज आ रहा है. Understood?
Sir, one more doubt.
Yes.
Sir, like you have explained the application in terms of industry purpose.
Yes.
But like if we want to relate in our daily life, so is there application like
daily life
which
is
we can-
I first thing I told that there is a foot pump. हम फुट पंप देते हैं ना, जो फुट पंपिंग करते हैं, दैट लोकल जो
Yes, sir.
एनालॉग मीटर जो प्रेशर रीडिंग होता है, so that is the boron
Yes,
tube
sir.
below may be used. So that is a real time daily applications. Okay. So that's why that boron tube below may be used. That is a foot pump. That is very simple applications. Understood?
सर आप फुट पंप
Yes, sir. Yes, sir.
हेलो,
Yes.
फुट पंप बोले ना सर आप?
Yes, foot pump.
सर इतना स्पीड में बोलते हो ना, मतलब सुनाई नहीं देता सर.
ना एक्चुअली नेट में थोड़ा स्टेबल थोड़ा नेट प्रॉब्लम हो रहा है, तो इसलिए थोड़ा वॉइस का स्प्लिट हो रहा है. ठीक है, हो सकता है तुम लोग का वॉइस
कट जा रहा है सर बीच में.
थोड़ा कट जा रहा है, ये हो रहा है, ये थोड़ा होता है, ये थोड़ा स्टेबल, तो कुछ मैसेज आ रहा है, कुछ सिग्नल आ रहा है. ठीक है, इसकी वजह से हो रहा है.
Yes, sir.
Okay, now you have understood all the topics working as these are elastic pressure sensors, boron tube, bellows, diaphragm, all the pressure sensors you have understood.
Yes, sir.
Now is it clear to all of you? This is this today's topic. Next day we will start from another pressure sensors. And last time that I posted some Google Classroom in the notes, so you have got it, received it in the first chapter.
Yes, sir. We did receive.
Okay, fine. Okay, fine. After each class, suppose pressure sensors, it will take 2 classes. Okay, so after covering the pressure sensors, I will share the notes again from pressure sensors. Okay. combining all of these, bellows, boron tube, diaphragm, and rest of sensors, remaining sensors. Understood?
Sir, there is one question.
Yeah.
Sir, according to the accuracy, sir, which pressure sensor is much used, like accuracy wise?
Accuracy wise
Yes, sir.
that you can say that bellows is the more accurate than bellows is more sensitive than boron tube. Bellows is the accurate. Boron tube also gives the high accurate results. You can say that boron tube also gives the accuracy, but bellow is a much more better than the boron tubes. Okay, much more better than the boron tubes. Bellows.
Okay, sir. Okay, sir.
Fine, accuracy.
Yes, sir.
Both of them provide the accuracy results. Okay.
Okay.
But bellows is much more better than. Okay, so there is the advantage.
Okay, sir.
Bellows over the boron tube. Fine.
Yes, sir.
Okay. Okay. Any other question? Is it clear, all of you?
Yes, sir.
34 candidates present. All of you clear?
Yes, sir.
Fine.
Yes, sir.
Okay, fine. Okay. Okay, roll number 1,
Present, sir.
roll number 2,